Now we're going to solve. We are going to solve a few questions on the problems on the laws of indices that we have studied. We are going to see how the application is done as per the CBSE. These are the extra questions that have been taken from exemplar and so on and so forth, different workbooks, and we are doing it. Okay. So the first question that is given is 20 to the power 7 divided by 20 to the power 5. Okay, so let's do it. There's division, so what do you do it? You do not, there are two ways to do it. If someone is wants to go with each and every basic step, they can go like this, and they can then do is 20 to the power 7 minus 5, because the bases are same, you subtract the powers, and then you get 20 to the power 2, which can be simplified as 2 square is 4, and zeros will become 400. Okay, but others who just want to come to direct step, what they can do is, since the bases are same, directly you can apply the law that those powers will get subtracted, and again 20 to the power 2 is what you're going to get, and the answer will be 400 is what you can do as well. So either this way, or you're writing this step and then doing, or you're skipping this step and doing, is one and the same. Okay, then the second question is a to the power 2x plus 3. I have to express this in the form of 2 to the power y. So how do I do that? So to express this particular thing in the form of 2y, I have to make the changes to the base. Okay, we are supposed to make the changes to the base. So what do we do in here? We are going to reduce the base. How can you write 8? 8 can be written as 2 into 2 into 2, which is equal to 2 to the power cube, isn't it? So instead of 8, now I'll write 2 to the power cube, and then whole to the power 2x plus 3 is here. Okay, that can be further simplified as this all will multiply, because that's like a to the power m whole to the power n is equal to a to the power m into n is what you do. So these two powers will multiply. So 3 2s are 6x plus 3 3s are 9. So here your y isn't it in the form of 2 to the power y? Now it is in the form of 2 to the power y. Some questions they will ask what is the y also. Find the y. So then you will write, therefore, if they ask find y, then what do you do? Therefore, y is equal to 6x plus 9. Okay, another question that they will ask is, what is the relation? What is the relation between y and x? Y and x. So how do you do? That means you have to find the value of x or y, what you can substitute into the equation to get it. Okay, so you can say that when you substitute 1 into the equation, it becomes so on and so forth, and or you can just leave it like this. This also explains the relationship between x and y. This equation also explains the relationship between x and y is what we get. Okay, now moving ahead with the next question that we can take in here. The next question can be p to the power, this is the question, p cube whole to the power 0 is equal to, multiplied by p to the power 1 by 2 whole to the power 4. This is the question given to us here. So how do I simplify it? Now these are in the form of a to the power m whole to the power n, that is equal to a to the power m times n. Okay, so what we are going to do again, we are going to write down the formulas in here. P to the power 3 into 0 into p to the power 1 by 2 into 4. So that becomes p to the power is going to be anything to the power 0 is 0 itself, and this gets cancelled. I'm left with p to the power 1 by p to the power 2 I'm left with. So this becomes 1 into p to the power 2. So ultimately p square is the answer for this one is what I get. Okay, moving with the fourth question that is given. It is given as 125 to the power 2 by 3 into 625 to the power 3 by 4. That means this number has to be reduced. Okay, these numbers are required to be reduced to a certain value, that I get it in the form of 3 power. Okay, or I have to write it somehow. So I know these are divisible by 5, so I will start doing the LCM method for this. Okay, prime factorization method. Okay, we are writing the prime factors of this. 5 2s are 10, and then 5 5s are, it will go, then 5 5s are, and so it can be written as 125 can be written as 5 cube is equal to 125 is what you get. Let's do for 625 as well. So x25 again, it goes with 5 times table. 5 1s are, then 5 2s are, and 5s are, then 5 25s are, because 125 is coming again here, then 5 5s are. So 5 to the power 4 is equal to 625 is what you get. Now let's rewrite them in here. Okay, I'm rewriting them here. When I rewrite them, how do I write them? So 25 can be written as 5 cube 2 by 3 into 625 can be written as 5 to the power 4, 3 by 4. So this are again in the form of a to the power m whole to the power n. That becomes 5 to the power 3 into 2 by 3 into 5 to the power 4 into 3 by 4. This is gone, this is gone. So it becomes 5 square into 5 to the power 3. Now bases are same again, add the powers is what you're going to do. So a to the power m into a to the power n is equal to a to the power m plus n. Write down these things so you score a mark. Okay, this will fetch you half mark easily. If you know the formula correctly, write it down. So here 2 plus 3, that is equal to 5 to the power 5 is what you get. Just leave your answer here like this. Okay. Now, going with the fifth question that we have. The fifth question that is given is 5 to the power m is equal to 3125. Okay. Find 4 to the power m minus 2. Okay, it is given that 5 to the power. Now moving with the next question, it is given that 5 given already, and we are going to start simplifying it. So how do we simplify it? Again, I have to bring this particular number in the form of, in the base of 5. Okay, I have to write it in the some base 5 and some powers should be there to it. Okay, so let's start doing the prime factorization method for it. Okay, so 5 6 it will go, and then 5 2 it will go, and 5 5 it will go. Then 5 625, you already know that 5 to the power 4 is 625. So okay, so what we are doing in here, 5 to the power 4 is this. So 5 to the power 5 will be this. Okay, so 5 to the power m is equal to 5 to the power 5. So what do you get in here? Since bases are same, you can equate the powers. You can write it down in here. Bases are same. You are going to equate the powers. Okay, so implies m is equal to 5 is what you get. Now substituting this m in here. So 4 to the power m minus 2 is equal to 4 to the power 5 minus 2, which is 4 to the power 3. If you want to expand it, or you can leave it like this also. 4 to the power 3 is 64. Okay, so that's the fifth question that we have. Moving ahead with the sixth question, it is given by 1 by 216 whole to the power of minus 2 by 3 divided by 1 by 27 whole to the power of minus 4 by 3. Now what do we see in here? The first thing that we are seeing is these are having the negative indices, and whenever there are negative indices, what is the next thing you're supposed to do? You are supposed to change the positions of them. So it becomes, it is a power for the complete thing, so the complete will flip. So it becomes 216 by 1 whole to the power 3 by 3 divide 2 by 3 divided by this also, it becomes 27 upon 1 4 upon 3. Then again, by 1 does not mean anything, so it's just like 216 to the power 2 by 3 divided by 27 to the power 4 by 3. Now how you are supposed to reduce it down? So let's start reducing it down by prime factorization method. So 216, how does it go? 2 table it will go. 2 how much times will it go? 2, let's say it goes as 2 1 times, and then because I'm taking the next step, I'm taking 2 zeros, I'll put 2 digits, I'm putting a 0 here, 8 times. Then 2 5 times, 4 times, then 2 2 times and 7 times, then again 3 times table, 3 nines are, then 3 threes are, that's what you get, 3 ones are. So it can be written as 2 cube into 3 cube whole to the power 2 by 3 divided by 27 can be written as, because 27 is there, it is directly 3 to the power 3 and 4 by 3. Now if the bases are same, we can add the, no, it's like a to the power m into b to the power m, that becomes ab to the power m. Common powers, right? So I'm going to apply the same rule in here. It becomes 2 into 3 whole cube into 2 by 3. The power was there already. Another thing that you apply here is a to the power m into n is equal to a to the power mn. So both the rules we have applied. This gets cancelled. Divided by this 3 to the power 3 into 4 by 3. This goes off. So what you get? 6 to the power 2 divided by 3 to the power 4. Okay. Now let's write it 6 into 6 divided by 3 into 3 into 3 into 3. 3 to the power 4 is there. Or else, because you have a 3 in here, don't do with this. Okay, don't do this. Instead, what you do is, you take 2 square into 3 square by 3 to the power 4. What's gonna happen now? You will get 2 square itself. These two have the same basis. They will subtract the powers. Okay, so write down a to the power m by a to the power n is equal to a to the power m minus n. I'm writing the formula, and that becomes 3 to the power minus 2. Okay, because what happened in here? If for this one it happened 3 to the power minus 2 minus 4, which is 3 to the power minus 2 we got. Now we got this. What is the next thing we are going to do? 2 square by 3 square. Because it is a negative power, I will have to send it back to the original place. So that becomes 4 upon 9 will be the eventual answer for this one. Now let's move with the next question that is given. So these are the type of questions that will be asked in the examination, okay? So the next question that is given is 1 minus 1 plus x square minus 1 to the power minus 1, and then I have minus 1. Okay. So this question, I know that I have to start solving from the inner bracket. Okay. So I will change it and write it down. Okay. So it becomes 1 minus, the outer brackets will remain as it is. Because there is a negative power to it, it will switch 1 by x square minus 1. Its position has changed. This complete thing's position changed. Okay, minus 1. Let's simplify this. So when I simplify this, because there's no denominator, I have to make the denominators equal. This complete thing multiplies in here. X square minus 1. Again, this plus 1 was already there. By x square minus 1 is there in the denominator to the power minus 1. Then this gets cancelled. I'm left with 1 minus x square by x square minus 1 minus 1. Then what am I supposed to do? Because there's a negative power again, I have to change the positions of numerator denominator. It becomes 1 minus x square minus 1 by x square. Now it's done. Now I can expand this bracket also. When I expand the bracket, it becomes x square minus 1 by x square. So when we do it, x square, making the denominators equal and multiplying. So x square minus x square, minus of minus becomes plus 1. Because this is like this, x square, negative x square, negative and negative plus positive. These two get cancelled. X square in the denominator, 1 by x square is the answer for this one. Okay. Next question that we have is 25 to the power 7.5. Okay, multiplied by 5 to the power 2.5 divided by 125 to the power 1.5 is equal to 5 to the power m. And they say find m. This is another question that we have here. Okay, so decimals in the powers, we never saw this. So what we are going to do is, we are going to change the decimals from decimals to the fractions. Okay, so let's write it down. 7.5, just taking the powers. You can write here, you are using the powers only karke, okay. 7.5 becomes 75 upon 10. Start reducing it with the 5 times table. 5 2s it will go, 5 1s it will go, and 5s. So it is 15 upon 2 is the power for this. Okay, next is 2.5 is the power. So that becomes 25 by 10. We are removing the decimal. So 5 5s are 5 2s are. So it is 5 by 2. And then 1.5 is the next power. That becomes 15 by 10. 3s are and 2s are. So 3 by 2 is what you get. Now let's write them in here. Okay, now let's rewrite the statement in here. So 25 to the power 15 by 2 into 5 to the power 5 by 2 divided by 125 to the power 3 by 2 is equal to 5 to the power m. Okay, let's break this and write it. So it can be written as 5 square into 15 by 2 into 5 by 2 itself you will have. Okay, divided by 5 cube into 3 by 2 is equal to 5 to the power m. Now here, if you see, all of them are having the denominator. But if I try to cancel this denominator, it will be difficult for me to add or subtract the fractions. Okay, so I'm going to keep them intact. This is a decision that you're supposed to get while you're doing the questions itself, and that comes by practice again. So here it becomes 5 to the power 30 upon 2 into 5 to the power 5 by 2 divided by 5 to the power 9 by 2 is equal to 5 to the power m. Okay, now bases are same, and in multiplication add the powers is what you're going to do. Okay, so you're going to add the powers. Then okay, so it becomes 5 to the power 30 by 2 plus 5 by 2. They are in division, so it becomes minus 9 by 2 is equal to 5 to the power m. Then add all of them or subtract all of them. 35 minus 9. So that becomes 26 by 2. 5 to the power 26 by 2 is equal to 5 to the power m. Bases are same, I equate the powers. So m is equal to 26 upon 2. That becomes 13. So m is equal to 13 is the final answer that you get. Another question that we have is a cube b to the power minus 2 into a square b square whole to the power 4. Okay, so what do? There's a negative power. The most important thing that catches my eye is the negative index over here. So I am going to send it down. It becomes a cube upon b square. Fine. Into multiplication, this is going to, each of the powers will multiply with it. So it becomes a to the power 4, b to the power 4. Okay. Then bases are same, add the powers. Bases are same, subtract the powers. So a to the power 3 plus 4. B to the power 4 is already there. This is going to subtract, so minus 2 will come here. Okay, so that becomes a to the power 3 plus 4 is 7. B to the power 2 will be your answer. Simple. Okay, so moving ahead, let's take another question which is given as a upon b whole to the power x minus 1, which is equal to b upon a x minus 3. Okay, so that's the question given, and they're asking us to find x. So how do we find it? Same thing. Now here, would you see, one of it is a by b, the other is b by a. So what I am supposed to do is, if I switch any one of their places, that means I'm going to apply, there is no negative index, I want to create a negative index here, so that they both are in the same format. The bases are same, I can equate the powers then. So what do? I will flip this only. So b by a is equal to, it becomes minus x, minus into minus plus 1 it becomes, is equal to b by a is equal to x minus 3. Bases are same, now you can equate the powers. So it becomes minus x plus 1 is equal to x minus 3. Bring all the x terms together and the numericals to one side. So what does it become? X is, 3 comes here. So 3 plus 1 is equal to x plus x. That is equal to 2x here, 4. 2 ones are 2s are. So x is equal to 2 is what you get for this one. Okay. Next question that we have is 2x to the power minus 4 upon x to the power 4. Okay, this is another question that is given. So negative 4 means automatically this is not in its position. I have to change the position for it. So that becomes 1 upon, it should go to the denominator. 2x to the power 4, x to the power 4. So 1 upon, this applies 2 to the power 4. This 4 is for this power 4 is for this as well. 2 to the power 4 and this. So it becomes 1 upon 2 to the power 4, x to the power 4 plus 4, that becomes 8. Not 16, but it becomes 8. That's another question that we have. Okay. Another 2 more questions will do and we'll shut this topic. So the next question that is given is 16 to the power, this is again a decimal question, into 16 to the power 0.04 into 2 times of 0.02. So here what I'm going to do is I'll change the decimals to again the normal questions that we have. Normal fractions. Okay, 16 to the power, 16 becomes 16 upon, there are 2 decimal places, so it becomes 100, into 16 to the power 4 upon, again 2 decimal places, 100, into 2 to the power 2 upon 10, 1 decimal place only. Okay, So that becomes how much? Reduce this down. Let's reduce it down. So it goes as, okay. So now I want to reduce these down, and when I'm reducing them down, it goes like how much ever I can reduce them down. Okay. So that goes as 2 times table. You can go with. So how much does it go? It goes 8 times, and 50 times it will go, and then again it will go 4 times, and it will go 25 times. So you can leave it at that. So it goes as 16 to the power 4 upon 25 into 16 to the power, let's reduce this down again. Okay, when I reduce this down, it goes as 4 ones are, or sorry, 2 twos it will go, and 50s it will go, then 2 ones are, and 25s are. So 1 upon 25 is what you get, and 2 to the power 1 upon 5 is what you get. Okay, now let's further reduce the 16 to 2 to the power 4. We can write it as, okay, 2 to the power 4 into 4 upon 25 into 2 to the power 4 into 1 upon 25 into 2 to the power 4, 2 to the power 1 by 5 is what we have. So that becomes 2 to the power 16 upon 25, 2 to the power 4 upon 25. Sorry, these are multiplication. 2 to the power 1 upon 5. So let's, bases are same, adding the powers. 2 to the power, I have it as, yes, 2 to the power 16, 25 plus 4 upon 25 plus 1 upon 5. Since the bases are not same, denominators are not same, I'm going to multiply with 5 on all of them. So that becomes 2 to the power, these will add to 20 upon 25 plus 25 plus 5. So that becomes 25. 2 to the power 25 upon 25. They get cancelled. I get 2 to the power 1, which is equal to 2 itself. Further ahead, we have another question. We have another question which goes as 5 to... Now, let's consider this question. This is another question that is given in the examination. So how do we simplify it? Let's take all the digits together because they are in multiplication, and then we have the bases which we can act upon. So it becomes 5. Okay, we'll keep them as it is because we have a bracket to open here, into 3. Now this power applies for both of them, a square and b to the power 2 3s are 6. It becomes multiplication divided by 15a square b. Now since the numerators are in multiplication, 5 ones are, 5 3s are, 3 ones are, 3 ones are. So what are we left with? I've left with a to the power 5 b square into a square b to the power 6 by a square b is what I'm left with in the denominator. Okay, now when I need to simplify it, bases are going to add up. Okay, or else, or now that you learned what they are in multiplication, so this and this will get cancelled also, exactly same things up and down. Okay, then here we are left with a to the power 5 b square into b to the power 6 by b. That becomes what? This, out of the 2 in here, one b gets cancelled and another gets cancelled. I'm left with a to the power 5b into b to the power 6. Bases will add, a to the power 5 b to the power 7. It will be the answer for this one. Okay, then the last question that we have is a to the power b is equal to 121. Okay, and then find a to the power minus 1 b plus 1. Okay, so first of all, we'll try to reduce this down. How can we write 121? We know 11 times 11 is 121. So a to the power b is equal to 11 to the power 2. So automatically I get to know that a is 11 and b is equal to 2. Okay, then I will substitute a and b into this equation. Okay, so when I substitute it into the equation, it becomes a is 11 minus 1 and b is 2 plus 1. So that becomes 11 minus 1 is 10. 10 to the power 3, that is equal to 1000 is the answer for this one. So these are the type of questions that are asked in the examination.